Okay, 7.6 is all about the natural logarithm. I'm going to show you where it comes from, what it is, and like all this stuff, because we're going to be able to solve equations with a natural log in them. So let's back up for a second, talk about where it comes from and what the deal is, okay? So you remember how we have been working with this expression, okay? Somebody read that to me. What's it say? Log base A of x. Okay, log base A of x. And then, do you remember this number I introduced to you before called e, which is about 2.71 or 2.718, blah, 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 right? Euler. It's called the Euler number, okay? All right. Well, it turns out, remember that this base down here, this base a, it's just a number. It could be 1.2, it could be a 3, it could be pi, it could be 17, it could be whatever. So what the deal is when we replace log, when we replace our base a with this special e, this special Euler number, log base e of x, we give everything in this box right here a new name. And that new name is the natural log of x, which is what we had before. Now, why do we call this the natural log when it's clearly an L and an N? Well, if you ask Mr. Novotny, it is it stands for logarithmic naturalis, which is the Latin root of what we say natural log. So that's why the L comes first, and there's a button on your calculator that has natural log, which makes total sense. It's right below the log button. Okay. The main idea here, ladies and gentlemen, is that a logarithm with a base of e is what we call a natural log. So all the properties that work for logarithms also work for natural logarithms, because a natural logarithm is nothing more than a logarithm with a base of e. Okay? And if you think about what the graph would look like, I have it over here for you. E to the x is very, very straightforward, right? Notice we have 0, 1 and 1, e. That's the point right here, 1, e, which is about 2.71 blah, 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 right? Well, look at the graph of the natural log, which is in blue. Notice the same thing happens. I still reverse my x's and y's. I have 1, 0, and look, I have I have e, 1, which is right about there. So we would say this point is e, 1, where e is about 2.71, blah, blah, blah. Okay? So all the same stuff still works for the natural logarithm. Okay, we're actually going to simplify this. There's nothing really to solve. We're going to simplify this. 2 natural log of 15 minus the natural log of 75. Okay. Well, the same kind of thing still applies. Like, where did this 2 come from? It came from up there, right? So that's going to be the natural log of 15 squared minus the natural log of 75. All right, so far so good. Well, that's the natural log. 15 squared is 225 minus the natural log of 75. Well, now I have a subtraction sign between these two natural logarithms, so I can say that's the natural log of 225 over 75, which is just the natural log of 3, which is approximately 1.25. You guys get that?
Yeah, I got 1.09.
All right, 1.09. Okay, we'll take that. How? That's a great question. Let's plug in the calculator. Here we go. Natural log of 3. Enter. 1.09.
It's 1.1. It's 1.1.
What does 1.09 actually mean? Does anybody know? What does that actually mean?
E to the 1.9 equals...
Very good. It means e to the 1.09 is approximately 3. Is that true? Oh my gosh, no way is that true. Yes, that is true, right? Check it and see. Where's the e on your calculator? Second natural log, e to the 1.09 and some change. Look, you get about 3. And there it is right there. So that's what we're doing with all this stuff. All right, natural log of 7 plus 2 natural log of 5. Where did this 2 come from? It came from the exponent on the 5. So the natural log of 7 plus the natural log of 5 squared is natural log of 7 plus the natural log of 25. Okay, so this becomes the natural log of 7 times 25 is 175. And then that in your calculator becomes what? Okay, what does that? Interpret that for me.
E to the 5.16 equals.
Approximately 175. Good. Okay, let's solve this natural log equation. All right. The natural log of x minus 3 squared equals 2. Anybody see any first moves? What can we do? Yeah, so 2 times the natural log of x minus 3 is equal to 4. I'm with you. Now, any other moves? Divide by 2. I like it. So the natural log of x minus 3 is equal to 2. Awesome.
You can say 10 to the 2. You can say 10 to the 2
It's e, right? This is going to be e squared equals x. Whoa.
It's the same as
So therefore, e squared plus 3 is equal to x. So x is approximately 10.39. All right, here we go. Let's solve this one. We're solving an equation with an e in it. No big deal.
bring the 2 extra.
So let's subtract 2 first, right? Let's go 4 e to the 2x
Oh yeah.
is equal to 14. Good move.
Log 4 e to the 2.
No, let's divide by 4 first. Let's simplify it as much as we can first, right? So e to the 2x is now equal to 3.5, because I know that one already. Now what do we do, Jake?
Well, you could make them into L.
Yeah, the natural log of e to the 2x is now equal to the natural log. Now, why did we choose to do a natural log?
Because it has an e.
Because it has an e in it, exactly, the base of e. Now, the cool thing about this is what happens to that 2x?
To the front.
It goes down in front, very good. So we have 2x times the natural log of e is equal to the natural log of 3.5. Now, ladies and gentlemen, hold on a second. What is the natural log of e? Why is that the number 1? Because that's log base e of e. Very good. So that's awesome. So then we have 2x is just equal to the natural log of 3.5. Then we divide both sides by 2. We can get that x is approximately 0.626.